Welcome to this Sahara 4 exercise. In this exercise, we will use the summation tool inside the petrophysical calculation window to create new variables, new petrophysical variables. In this case, we are going to create a thickness and a porosity that will use a cutoff value of 15%. So we will not overwrite the petrophysical data that has been imported previously in as petrophysical data for the wells for each layer and well combination, but what we will do is create new variables that we will call hk15 referring to the thickness with the cutoff, and phi 15 referring to the porosity also with the cutoff applied. So the idea is to use this summation tool to calculate this petrophysical data from the electrical logs that we have loaded in the project, and then apply the cutoff to finally calculate this thickness and porosity. So now let's go to our Sora project, and first let's create the new variables. We're going to create the variables here. They're going to be petrophysical data, and we will create first the new net thickness. We will call it net thickness 15 referring to the name of the cutoff. Again, this as well. We can create the variable with the same reference. The data type obviously is going to be decimal. Variable type data, because we are not going to calculate this net thickness from other petrophysical data. We are going to uh, create it based on as we discussed, based on the electrical logs. So it's going to be type data. The only group is going to be thickness. So here we should have thickness here. We won't use any link map, so we are not going to create any map with this thickness in this opportunity, but if we wanted, we could associate a map with it. We won't use any keywords because we are not going to import the information. And in the case of this is important, the aggregation function here, that in the case of thickness is going to be sum. So we will save it for now, and then let's create the other one, the porosity, that is also going to be petrophysical data. Let's call it phi 15. We will use the same name for the short name and the reference. Is going to be also type data, going to be decimal data type. Unigroup here is going to be porosity. Here we are not going to select any link map, and also we are not going to select any keyword because, as we discussed, we are not going to import this. But now here we are going to do something quite different. For the aggregation function, we are going to define it as weight arithmetic mean, and the variable that is going to weight this arithmetic mean is going to be the net thickness. So now the aggregation function is going to define that when we have several values of porosity, the function that has to be used to aggregate the different porosities of phi 15 are going to be a weighted arithmetic mean, a weighted average of the net thickness. Now we click save, and now we have our two variables created. With our variables created, we will now go to the objective of this exercise, that is to use inside petrophysical tools the summations window. Here we can select a log to base the new petrophysical data that we are going to calculate. So in this case, let's start. Here we can define if we want to use wells and layers or zones as the calculation. Here you can select different zones. We don't have any in this project, so we are not going to select any of them. But here you can define the type of object you want to calculate your petrophysical data on. So we will do it for well and layers. Here we have some advanced options regarding the calculation. You can review them more in detail in the user manual, the user guide. Here we select the wells that we want to perform the calculation on, and the layers where we want to perform the calculation. And most importantly, here, variables to calculate, we will add two rows here. And in the first row, we will define the variable that we created, net pay, yes, 15. So net thickness 15. So the operation is going to be summation. The log where we are going to base this this calculation is going to be depth, and here we have the option weighting. Here you can review more of these calculations on more detail in the manual guide as well, but this is going to be important for wells that are that they have surveys, that they have the horizontal wells or directional wells, because the definition for the net thickness might vary depending on the inclination and the azimuth, and the relationship between those and the geological angle of the layer compared to the horizontal line. So in that case, you can review more in detail which of the different options mean in the user guide as well. So here the condition is going to be defined with the equation editor here, and as we discussed, this is going to consider a cutoff of 15%. So we are going to define the cutoff from total porosity more than 15. So now what we are basically creating here is, again, a variable that will consider, let's see if the units are correct, yes. So we are going to, in each different layer, sum and the layers are going to be defined with the top and base defining petrophysical data, the peaks. So we are going to, inside each of the different layers, when the porosity, the value of the porosity log is more than 15%, is going to add up that thickness to the variable that we have created. So we are going to have a cutoff that is going to depend on the porosity. Only is going to consider those values inside those layers that are above 15%. So this is the cutoff, the new variable net thickness with the cutoff. So we are going to do the same now for the porosity. We are going to select our variable here. The operation here is going to be arithmetic mean. Arithmetic mean. The log is going to be based on the total porosity. Here we won't be able to select the option weighting here because this is going to depend on, it's only going to be available for thickness, and the condition has to be defined as well with the equation editor. So we are going to consider a porosity bigger than 15 as well. So again, what this is going to do is to average all the porosities that inside each layer that are above 15. So basically, inside each different layer, we are going that each different layer again is going to be considered, but the top and the base that has been imported as petrophysical data, the peaks, we are going to do an average of all the porosities of all the total porosity that is higher than 15%. So now we will click with these two variables defined. We are going to click on calculate. And now the two petrophysical data that we have created, the two petrophysical variables that we have created, have been calculated. As you can see, we have the total records of all the calculations performed, each one for net thickness and one for porosity, in each combination of layer and well. So now we will click OK here, and now let's check if the calculation has been performed correctly. So we will plot new bubbles here. Let's create bubbles that will be bars because we want to see more than one variable. I will erase the previous variables that I have selected here, and we will select the new ones that we have created. So net thickness 15 and porosity 15 layer. And now we will do some modifications here. Let's consider for net thickness this color here, something a little bit brighter, and for porosity yellow. So now we have, let's also include the data values here. So now we can see the different values of porosity. For example, in the layer 7 that we have here, we have a net thickness of 21, That means that inside this layer, the total thickness that is going to be considered for this layer between the top of layer 7 and the base of layer 7 that has a total porosity higher than 50% is going to be 21 feet in this case, because the units are feet, and the average of all the values of porosity, of total porosity, that are higher than 50%, the average is going to be 20%. Then if we want to, for example, select more than one layer, we can do it here. Now the sum of all the thickness in the in all these layers that is higher than which the porosity is higher than the total porosity is higher than 50% is going to be 42 feet, and the average of all the porosities that are higher than 15 in all these layers is going to be 19% in this well. For example, we are reviewing the well 39. Remember that in this case, what defines that here we are going to do the sum and here we are going to do the weighted average is going to be the aggregation function that we define for each different variable. That, as we discussed, is going to be sum for net thickness 15 and porosity weighted average based on net thickness for porosity. So we have this calculation performed for the different layers that we have selected. So basically, we have created two petrophysical variables that we have filled up with information based on the electrical logs that we have. There are certain things, as for example the TBT and TBD definitions that you can review here in the user guide, that are explained in more detail. But basically, it's only important if you have directional wells, like for example an horizontal well. In the case that you have vertical well, you can use TBT without any issue. But have in mind that if you are going to perform calculations like this for wells with surveys, it is a good idea to review the definitions of the equations for survey for directional wells in the case of the sum of the thickness. And the creation of a new net thickness, for example, like this one that we have created. So that will be everything for this tutorial. Thank you for watching and have a great day.